I am attempting to record this because I was told nothing's being recorded. So I'm going to try to record this and provide the video. We'll see what happens. I don't know if it'll work, but we will try. Okay, back to the schedule program. So the quote in that show, he doesn't like to travel, and they gave him a travel show. So his line is, "We're here, but should we have come?" And that was my idea for this, is like, should I come to this one? I've been to like Montreal, I've been to Halifax, New Orleans. I like doing it, getting, the company to pay for it. Not always easy, especially since I'm not one of the committers. But this year, fortunately, my company we got a good sponsoring shop. We got a booth. We got some people here, especially if you looking, there's still some iceberg talks left. I think we have Polaris, some good stuff. I'm in New Jersey, if you didn't figure out the voice. I cannot have the non-American problem there. I sound like I'm from New Jersey or New York. There's no, maybe there's a class I could take, but this is what it is. I've got a weekly newsletter, covers a lot of Apache projects. What's nice in my newsletter, you don't have to subscribe to it. I put it in GitHub. I put it elsewhere because some people don't want to go to GitHub to read a newsletter, but I put it everywhere. I need to come up with a project that'll send it everywhere, but not every place you could put a blog or a newsletter is friendly to free APIs. Because if it was, I'd have NiFi publish my newsletter, but haven't done that yet. So when I was thinking of this talk, and then I'll get into the overly technical part, is like, part of this is all the projects really circle of friends. And to me, this is because NiFi is a little different from some of the other projects, is it's not standalone. It really is built on a lot of Apache layers of goodness. Like Tika's in there, Calcite's in there. Almost everyone uses it together with Parquet and Avro and Kafka and Polaris and Iceberg. So it's a big, happy group of people working together. And as soon as you get here, you remember the people from other projects or from other events or from, you've seen them before. And I was just thinking about, I saw the room, all these rooms are islands, and I'm like, no project out there is, or any developer is an island. And that's what's great about the community. And that's one of the reasons I'm like, yeah, you have to come. I was trying to justify this to my bosses that are like, well, are there customers there? And I'm like, well, technically, yes. There's some customers from two of my clients here because they're committers, thank God. But, you're here because you hear stuff about new stuff coming. You see a new project, even if it's not a regular one. Hearing about the one to do slides, that could be very interesting. I got to look at that, especially if it's something that I can, connect and build automatically. That might be very cool. Other one is, don't try to do everything, and that NiFi doesn't try to do everything by itself. Because I get a lot of people going, well, are you replacing Kafka? Are you replacing Flink or Spark? I'm like, no, we're all friends. I can do something good in NiFi, but some things don't make sense to be there. So don't try to do everything on your own. Don't do everything in one project. If it looks like it's a stretch, maybe it is. Maybe it's been solved already. Like, should I use NiFi to queue data? No, I think Kafka does that really well. Because we were talking about it that in the hallway, like 2 hours ago, should I use NiFi for this? I'm like, well, maybe you could do it, but why don't you do it in Flink SQL, push it to Kafka, then I finish it off in NiFi. Or I start it in NiFi, push it to Kafka, share it. I'm like, it'd be cool if I directly integrated those, but I have something that's a universal integration layer. It's open source, it's Apache Kafka. Why not use that? I mean, sometimes people think, well, I want to write my own thing. Use what's out there. There's more projects in Apache that people don't realize, that you don't think of, and you're like, oh, let me use this other thing, or let me develop it myself. I have found some when trying to look for, how do I do this? Is it in NiFi already? Okay, maybe not. Like I wanted to do NLP, and I'm like, okay, maybe not all use cases are there, but OpenNLP has a couple. So I created a processor in NiFi to use that instead of trying to write it on my own or find a library. That one worked really well. If you were in my talk before about the Python processors, that opens up a whole new ecosystem. But the problem with that Python ecosystem is it's not as well thought out. Some of those libraries, it's one person working on their own. How stable is that library? I don't know. For some of my stuff, I don't really care. It's kind of, just me doing it on my laptop to try something out. But if I'm using Kafka or if I'm using OpenNLP, those are projects with governance and all the goodness in there. I know things are tested. There's multiple people involved. There's, all the reviews and stuff that make sure that it's not some coding slop or not some AI generated project someone did yesterday that maybe every time I call it, it's running a small amount of Bitcoin mining. You don't know. I know there's no Apache project that does that, though that might be a new one. Apache add Bitcoin mining to your project. And that's my new one, and we'll come up with a cool little symbol for it. Hopefully we want to let that one in, but you never know. They could do a lightning talk on that. Who wants to join me on building, a slop project that adds Bitcoin mining to your things without you knowing? I don't know that's a good idea, but talking out loud about it, it doesn't happen in other communities. So this is cool to have. So I came here, I learned about 3 new releases, 3 new projects, found out some of the older projects have gone to the attic. I was kind of curious about. And so some that I thought were going to the attic that didn't. So it's always kind of interesting there. My next talk is somewhere far away. I don't know where it is. I got to find it. That one, these 2 were going to be the same talk until I realized this is the community track. And I'm like, oh, I just assumed all my stuff was in streaming. These are going to be really similar. The difference is that is really kind of focused on making things for figuring out how to travel easier. Here, I thought of part of the community part is it worth making this trip? Well, we're all people for data and logic and decision. So I'm like, well, let me get data and see if it's worth it. And then when I looked at all the data, I don't know if it was worth it. I love the project, but there's you have to pay for a flight. It's worth it, but it's hard to make the data good enough and in enough analytics on it that I could hand it to someone who doesn't know anything about Apache, doesn't know anything about the community, and they can look at the data and go, yeah, this is a decision you could do. I can't give this to a boss and go, look at this data. Obviously, I should go to the conference. I was hoping I could do that. But it's really kind of hard to figure that out because some things don't have open APIs, like Uber. So, when I'm paying for an Uber, I can't really make that decision as well. I can maybe call one of their APIs, but a lot of those are locked down. Fortunately, I can get some data. I can get data around plane arrivals, how long it takes to get there, transit. I was surprised the name of the transit system here. I've written an open source component for NiFi that reads any GTFS RT, which will go into the next talk what that is. And I found out that the metro system here uses that. So I'm able to watch the buses. And I'm like, oh, that's kind of cool. But I mean, if you're already here and my hotel is here and the venue's here, I don't really need the bus. But it's cool to see the data there. So I'm like, I'm going to store a bunch of data in Iceberg, and it's going to help me. I looked at travel advisories. There's no travel advisories going to Minneapolis, which is good. There's no weird regime here. And then I got some stuff on the different transit options. Again, don't really need transit to get here. If I was closer, I live in New Jersey, I could have used mass transit and figured out that math. That would have been easier. I did it for some plane data. Some of it's running off an antenna. Some of it's running off public APIs. Looked at the weather. The weather was going to be really bad. You can put that into your decision making. But I don't think that's, we're indoors the whole time, so it's not really too much of a thing. Air quality, not a huge one. This one is more relevant for me. One thing you have when you go to a conference is a lot of people. Air quality can be an issue. Now, the one thing I would love to be able to track is airborne germs and stuff. I don't have a sensor for that, but I got a sensor for some things here on the floor. So I'm checking, was it worth it for me to come and speak at this podium? And we'll look at the sensors to see if it was a bad idea. Um, Twitter has closed down their API. You can only get it from an expensive paid one, so it can no longer mine the huge amount of bad data that's on there. You can get Blue Sky, and it's a cool source to look at, but Blue Sky, unfortunately, does not have a ton of traffic around community over code. So I couldn't get enough data from that to make an interesting decision. Yeah, what's cool, though, the local transit system is called Metro Transit, and I'm like, is that a fake name? I was like, did someone come up with a test transit system to try out the data? And I'm like, even the way they name things and the way they have their APIs for the different types of feeds and real-time transit. And I looked on the buses here, and that's on there. That was the name they came up with, Metro Transit. So it is real. So we got real data from there. So I was figuring, but I didn't write it because we don't really have cool other places to go, is to write a real-time graph. Could have put it in Superset to show you what the current bus times are. But again, we got like one bus stop, so that's like not really a massive information radiator. This is my chart, and the cats are not Apache. These are mine, so sorry guys. You can't use that cat infrastructure. But the main thing to look at this data, NiFi is usually good at grabbing the data, getting it moved to the next place, maybe doing some enrichment, a lot of that using, like I said, other Apache projects, and then getting it along the way into integration, and then landing it into Iceberg tables. If you haven't seen the 700 Iceberg talks, Iceberg is a really big deal for storing data because it has some really next level features that some of the older Apache data projects didn't have. Being able to do things like time travel and having just the ability to store a lot of data easily in an open data lake of your choice is really nice. I highly recommend looking at those talks. They are really interesting. Now, why NiFi is a good project for dealing with this kind of data to help you decide if you should come to a conference is because it doesn't just deal with one type of data, because there is a lot of sources of data. It works with images and HTML and PDF and documents and zip files and all kinds of weird stuff, which not a lot of projects let you do that. But there's also data that's not weird. Well, maybe it's weird, but at least it's structured-ish. You know, things like Avro, good project, Parquet, being able to read XML, being able to grok log files. Some of these are specific to certain industries like IPFix. Syslog's a great one we could ingest and see as records. And once I see something that looks like a record, now I can easily get that into a database table because it's structured. And what's nice is to be able to take the thing that's kind of structured and instantly make it structured. Makes things really easy. So I don't have to type in field names. So this makes it really easy to rapidly do stuff, which is helpful for anyone with another project who wants to get data before you start testing whatever project you have. NiFi lets you drag, drop, and push it where you need to go. You need to test from a CSV. NiFi can grab a JSON file, turn it into CSV, put it where you need to do it. Great way to act as a piece of the tools to be able to help your project out. And whether you use it just because you can drag and drop this and not have to worry what the fields are or if they change. And if you need to use something like glue for your schemas, you could just use that. So if you do care if there's 12 fields versus 11, NiFi can automatically tell you that, or tell you that's bad data, or just let you ignore columns you don't care about. That's up to you. And there's a couple of open source Apache schema registries you could use in there as well. I'm going to show some demos again, which makes sense in a community event there. But I used your advice. So later, I didn't put one QR for this because I'm too lazy. But the slides will be available. I put them on GitHub, and there's a link to a ton of different articles related to how to do some of these things really easily. So, you don't have to be concerned of, Tim said it, but can you really do it? Well, I'll try to show you as many of these as I can and then give you some time for questioning. Unfortunately, I didn't use the cool timing one, so I got to kind of keep my eye on the time. I do like that. I would like to have that just sitting anywhere, like how much time is left. That should be an Apache time project. We have an Apache time. Something to work on. Somebody want a new project. No one's busy. Okay, so this one is to do air quality. There are a couple of open APIs for air quality, and NiFi can read them. I have a list of the top geo areas in the country. They happen to sit on a public GitHub. So NiFi has the ability to read any REST endpoint. So I could literally just drop something on here and ingest any kind of HTTP endpoint, whether it's REST, a web page, whatever, even if it's secured, if it's on SSL, if it's got OAuth, if it's some other kind of security you get. So for here, I run that to get the popular air quality areas. Now, I could just do it for the closest one here, but then I get one record, and that's too boring for me to run one record. It would make sense, but I'll ingest all the records for the top cities in the country, put them in an iceberg table, and then you could do analytics on it. I could make the decision to just, if this was just for me personally, maybe I'll just read the one that's here, and then have one record and it'd be really fast. But here we had 30,000 records. Then while I'm talking, it loaded. And this is the one for Alabama. So I use this data to ingest the next step. And the next step is to parse that out, get the zip code, and using the zip code, I can call this API from the AirNow Association that gives you open access to air quality data, which is, good to know if you travel here and maybe you have breathing issues. If air quality is a concern for you, you should probably check it out because it does vary different times of the year, different things going on, especially we get these forest fires in Canada and you don't know what's going to go on. So we get that data, and I found out that if I send 50,000 individual calls to Iceberg, one row at a time is not good for any kind of format like Iceberg or any of the old Hadoop formats because you're writing it once. So as opposed to something like a Postgres database or some other relational database, doing one record at a time is never a good thing. You cause problems with making too small files, and you have like 100,000 Parquet files, and you only have, 1 million records, and it's only 2 gigs. That's not going to perform well. Fortunately, NiFi has a universal thing to handle that. With merge record, I just, merge a bunch of them together, and I could do it based on size and time, and then I could just do an insert. And again, nowhere is mentioned in here what are the fields, what are their types. I just know. NiFi has the record reader that's either going to use a registry, which could be Glue, it could be the Cloud Era Schema registry. There's a couple of open source ones. We could also look at a relational table and use that as our schema, and then it'll auto-validate your fields against that. I'm using the infer, which is, I forget which Apache project has one that'll infer what data is from looking at it. So it'll look at a sample of your data, and say, okay, this seems to be a string. Now, is it 100% successful? No. It's going to default to string if it doesn't know. So you got to check later if you wanted string. Some of the, depends where you're pushing it. Some things are a little more forgiving if it's close type and it'll auto cast it. You might have to do casting on your own, or you might want to go, okay, I know what this is. Let me use a schema to validate it so that I know what I'm doing. But NiFi gives you a couple options here. It's going to try to translate the fields because, some people like to make things uppercase, some people have lowercase, and then here I know the iceberg doesn't really love underscores, so I'm going to remove those. I can remove things like spaces automatically, and I don't have to write any code. I could even have a regular expression in there if you have some unique style that you want to do. And here, if someone happened to throw some extra fields in there, I'm not going to blow up. Just ignore them. That's definitely something you got to think about, though, if you really want to throw away columns and stuff. But up to you if you don't get them. Yeah, whatever you want to do there. This one failed, but some succeeded. What's going on there? Now, what's nice with, it missed out of range. See, it didn't match the field. What we find in free data, it's not always perfect. So what's nice with NiFi, if something fails, I can retry it because maybe something was going on. And here what will happen is I'll retry it 3 times. If it fails on that, I'm going to send it over here, and then I can make the decision. What do you do with the records that failed? I can put them in a file, can put them in Kafka. I could send them to Slack channel to tell people, you screwed up, Tim, and then take a look at it. That is kind of up to what people want to do. Lots of options there. Now, the other thing that's kind of helpful to know when you're going somewhere is to get the weather. Amazingly, NOAA still publishes all the weather. There was a little while where federal government took it down, but it's back up, fortunately. And again, this is another one where it's nice with NiFi. Test things a couple times. If it doesn't show up, try to use an alternate API. What's cool here, most people wouldn't want to get this in their API, is a zip file of XMLs. That's usually not the URL you want to be downloading in REST. Again, NiFi is like, okay, you want it all in a zip file, all XML files, sure. Uncompress, take all those zip files out, and then I look at all the zip files and only grab the ones that start with the letter K, because I found out there's a lot of NOAA sites that are like in the middle of nowhere, and they're like research stations or on remote islands. I don't really need that data, and very often they're very sporadic. So I know the ones start with the K are airports. Those are universally valid places where they gather the weather. So I just look at ones that have a file name started with K. And then I take those XML files, thanks Noah, and convert them into JSON and using this little SQL. Amazingly, sometimes they have ones that just say the location is, I don't know. I don't want that data. I want some kind of geo data to let me know where it is. Because if it's just some weather somewhere, I guess that's cool, but that don't help me. So while we were talking, it grabbed all that. We're going to merge it again because small file problem. Once they get merged, send it to another iceberg table. Again, you're seeing if grabbing data, pretty easy. What's kind of cool, though, is if something fails, I retry it. And if it fails too many times, I do whatever I want. What's kind of cool with NiFi is it is drag and drop. So if I really can't get nowhere, maybe the network went down, just grab that real time and change where I'm going to put it. So if data has nowhere to go, send it to my temp directory. Replace any existing data, why not? Create that, sure. And if this fails, see, that's the thing with NiFi. I can keep continuing. Well, what if I can't put it to the file system? What should I do? And I'm like, well, let me try. I can try to put it to S3. If that fails, then I'll send it to a Slack. If Slack fails, then probably I give up. What's nice with NiFi is we don't have to give up. In between each step, and this is where I had that Kafka debate before, that is a queue. Now, is it a Kafka distributed queue? Technically, it is a distributed queue, but I'm not going to use this instead of Kafka. This little line between every step in a NiFi flow is a queue that exists in a cluster and has some unique features for something that is just sitting in between two steps in a pipeline. It, here is this whatever relationship coming in. It's got a unique ID and you can name it. So what that means is I can programmatically access any step in a NiFi flow from either NiFi, REST, or the command line, or a third-party thing like Terraform or some automation tool. So I can know where something is and follow data through a system and start and stop individual things, which gets kind of crazy how much stuff you could do there, but you could have fun there. For normal people, just having back pressure. So if I do have things fail, I'll just let it sit there. It is not going to be lost. I have back pressure sitting there with a certain type of how many objects I can hold and how much space. So I could store a gig of data here. Round robin is how I let the data go through this pipe, because this pipe is sitting on as many NiFi nodes as I have. Right now, this is NiFi on my laptop, so there's just one node. But I could take this same code, distribute it on a 1,000 node cluster, and now it supports petabytes of data coming through it. That is the nice thing. You never saw me write stuff that says this is distributed code, this is standalone, run on one machine code. You don't have to worry about that. But can you control it? Yes. So here I could decide how I'm going to partition data between these 1,000 servers. Most likely 3. 3 is a good number for servers, or 5. But I like to think 1,000 because we ran that once and it ran really fast and was very cool. I never saw that cluster again, but I still think about it. Missed that cluster. Yeah, that was nice. I'm glad I didn't have to pay for it, but it was cool to have. Or sometimes you don't want it distributed. There's some things you do not want to distribute. Like I don't want to distribute reading from a file system. I don't want 1,000 people trying to share the same couple of files. I don't want to have 1,000 people read from SFTP. I don't want 1,000 people popping the same email. So sometimes you want to be single node, where it doesn't matter on this one, but if I picked up this code and ran it on a server, now it's only going to use that one, which wouldn't be good for this app, but for most people it's fine. I could also decide to partition it by a certain attribute in the metadata. So if I wanted, and I had a client wanted this, they want everything from one state to go over here, another one go over here. I could distribute to different servers that could be maybe in different parts of the world, or have different downstream databases they're talking to. So I could keep that as a whole pipeline so they can be in order. So I could do exactly once in order, pushing data somewhere. Now, does that take some extra work and you got to think about it? Yes. Most people don't care, so it doesn't matter. I can also compress part or all the data while it's going over this pipe. It is a very short pipe between these two steps in a process. But what if that process is going from my machine here to Amazon cluster? Maybe I do want to compress it because I know I'm paying, ingress charges and I don't want to. Well, let me compress everything when I send it there. Obviously, that's going to take time, so I don't do that running on my laptop. But if I was going to push a big file to Amazon, that's a good option. Again, no coding here, and any of these parameters can be changed dynamically while it's running. I could also prioritize data as it's going through all the steps by changing it here. Because, maybe I have a big file that runs once every hour. It's a big file. It's always there. It's not super important, but sometimes on that same channel, I have one message coming through that is critical. So I can have that prioritized over that big load. Don't have to have separate infrastructure to handle that, and it'll just do it, which is very cool. The other option, though, is NiFi can have infinite number coming out of here. I say infinite, but then you would look at the screen and there's like 10,000 lines here, and that's really hard to look at. You could do it, and there's programmatic ways to do that as well, but it's kind of crazy. Like if I wanted here, now I've got another option of the same relationship. So when the next record comes through, like if I send another copy here, I'll run it again. The weather only changes every hour usually, but we can still run another one. So when that merge is done, it'll send it another copy over here. Now, I don't know what to do with this data. I could just throw it away or whatever, but it's stored there forever unless the disk crash, which that is always the bane of NiFi, run out of disk space. We like to store stuff, and your queue can have a lot of stuff in it. Right here, it's waiting. This is one of the other nice features of NiFi. Data's just waiting there. I stop the next step. I don't lose the data. If this queue fills up, it'll stop this guy. And then it'll pile up in this one. And then all the way back to the start, and then it'll tell the start to pause. Whatever processor that is, will pause until you start clearing these out. Or if you change the size of your queues to give you more space, some of the queues can be dynamic, and there's an algorithm, and you could do some really complex things if you needed them. Most people don't need them, but yeah, this is just going to sit here, and it could sit there forever. And you could see that that's sitting there because we'll go to connections here, and I'll watch this one going, oh, there's a lot of data sitting there. Now, any of this data, which is kind of cool, the NiFi UI is a separate UI from the cluster. It doesn't need to run there, and it can be turned off if you don't want to see the UI. Obviously, that makes it really hard to program because you'd have to do it either through API, which is kind of hard to develop a drag and drop program in API, but you can do it. What's unique here is every call from that UI is a call to a REST endpoint here. So when I do this call it's going to get a network call here. Where is that in here? Network. So it's making a call for every API to get the data. So there is a NiFi endpoint for showing the current user, and it returns back the JSON for that. So the UI is built dynamically from that. 5 minutes? Oh, let's go into questions, because otherwise I can show you random NiFi stuff for the next 2 days. 2 days. And that's probably too much. Is there any questions or things people might want to see or direct? More of the sensors are going to be in the next talk at 4, which is deeper dive into real-time transit data and some of these same sources. And some of the sources running from the floor, which is actually getting pushed into Kafka from the floor to my phone to Kafka. Because the network here, I don't have to tell you about that. And then I just read it in. So I didn't get to this one because there's too many things on the screen. Because it's really easy to write NiFi code. So as you can imagine, there's a lot of NiFi code. So here is where it's stored. It's in the sensors. So I go down on the floor and send a little more code here. And that's sending, well, again, here you can see some records showing up. It's running every couple of seconds. So it's going from the floor to phone to a Kafka in Amazon somewhere. And then I pull it down. There's a couple more records. So we could consume Kafka really easy. Any more? There was no questions. Oh, yes.
Yeah, I was wondering if you could give some examples of the largest NiFi systems deployed.
The largest one was our test one that we put out, a 2,000 node cluster. I had a couple of, well, I can't mention the military ones, but they have very large ones. I did not mention NiFi is unique among our projects here, other than Accumulo. NiFi came out of the NSA. It was open sourced by them when they had a little thing to open source some of their projects, and then Hortonworks and Cloudera helped run with it. But yeah, they're the largest I've seen besides the ones we've used for testing that aren't military or NSA or government. There are a couple airlines that have 200 node clusters. I've seen a bank with a 100 node cluster. The problem is that's a lot of data. Most people don't need to process at that speed. I mean, because a 3 node cluster running 64 gig of RAM on each one will process millions of records a second. So once you tend to get to the billions of records a second, you start going into the trading systems in C++, or you start going into like Flink. If you're hitting that level of super sized data to ingest, Flink is great for that. But again, people tend to have Flink clusters with massive amounts of RAM. So we don't need that much RAM for NiFi. The sweet spot we found for the 2,000 node cluster was just 32 gig of RAM and 16 cores, and just having a bunch of them. Most people will just have 3 to 5 nodes running, and that runs most enterprise level use cases, a few thousand rows a second, petabyte or two a day, nothing serious. If you have a lot of data, NiFi can be run by Kubernetes, and you could scale it up while you're using it and then scale it back down. You really only need the magic number 3 to keep it going. Right now, it's Zookeeper doing the management. I know everyone's favorite. I don't know if they'll ever move it. It has worked pretty well, but the fear of Zookeeper not being too super popular, but we'll see. Hopefully, we don't have to do that anytime soon, but there are ways to not use Zookeeper to do it, but yeah, maybe we'll follow what Apache Pulsar did, and they've got some options there. But anything else? I think we're close to time. Very cool. Oh, we're at 25 records. Maybe I'll shut down my sensors on the floor over here. Oh, I guess we should look at that sensor before we wrap up here. What does this data actually look like? And is it helpful? Do we have valuable sensor readings here? Who knows hex? No. Okay. There's somebody in here who knows hex really well, and they're not saying. So what do we got? Anything that looks really scary. Temperature. No. In Celsius. Pressure, air pressure. Okay. Humidity. Ooh, humidity's a little low. So that does explain a lot. With air conditions at a place, you do get that. Nothing weird. During the forest fires that we had the other year, I got some crazy values on some of the readings, and it was a little scary. Like PM2.5, it's usually never high. Like, this is the most boring sensor, except for when we had those forest fires. I was getting numbers in my house with the thing sealed HEPA filters of over 300. So not good for, and I'm in New Jersey. I'm not close to Canada. That was when we had the orange skies coming out. That was not a good time. I did write an article about that. I tried to simulate that later in front of an open fire, and the numbers were drastically lower. Literally having a campfire 2 feet from my computer, which I don't recommend that. The values were lower. Nothing caught fire this time. But you lose a pie every once in a while when something catches fire. It's part of the business. You don't worry about that. It never got that high. So it's okay. We should be here. Thank you.